Thank you. Good morning to everybody. So I'm going to demonstrate, or we are going to demonstrate you the new mindBEAGLE. So this is me, but I also have help here. And besides me is Sarah, who volunteered as a subject. And on the camera we have Chiara. Thank you also for joining us. Right, so let's start explaining a bit of the new hardware. So we'll stop screen sharing for now so that we have a bigger video. Just stand up. Turn on the microphone. So basically, mindBEAGLE consists of a laptop computer, of course, to do the signal processing. That's clear, same as with the coverage. Then we have the Nautilus headset, EEG headset, having 16 active electrodes. And you probably already know this strand. You can easily plug and play to connect EEG caps to the amplifier. You will get EEG caps in different sizes, small, medium, and large, and you could also have more of them, of course. So if you have a lot of patients on a daily routine, just swap the cap, let it dry, have it cleaned, let it dry, and you can, in the meanwhile, use another cap. Or if there's something to replace, also you can ship just the cap to us. We would replace broken electrodes if that ever happens. And yeah, you already know the Nautilus. Then we have the G audio box. This is this small box here for providing auditory triggers or stimulations. So you have a standard audio plug to connect any headphones to it. And on the back side, we have USB-C. So the box is connected via USB-C to the laptop computer. And then there's a small other plug for the trigger cable. So we provide real-time trigger information to the signal, to the system, via the audio box and via the tactile box, so that we have precise timing of every stimulation event. And then we have the g.tec box, has the same size as the audio box. And this is to provide up to 7 vibro-tactile stimulators. So you see here the 7 cables coming out of the box, they're fixed. We have these kinds of vibro-tactile stimulators now. 2 of them are color-coded. You would see later on why that is. The others are not color-coded. 3 of them are already fixed on a volunteer subject, and the others we will just place during the demonstration. Yeah, so the rest what you see here is partly just for the sake of the demonstration. So usually we don't have these boxes. This is just so that you will hear the sounds later on. And of course, we have the polycom so that you can hear us during the demonstration. And here's just the base station of the Nautilus, where the trigger signal will be fed from the 2 boxes. So I'm going to connect the 2 boxes now to the rest of the system. We have these 2 trigger cables. They are interchangeable, so it doesn't matter which one goes to the tactile or audio box. Just connect them. And I also need the USB-C connection. And we see a small LED indicating that connection is correct. It's like an audio box. I almost forgot to say these boxes, the audio box and the tactile box are used in mindBEAGLE, but you can also purchase them standalone to be used in the g.tec in our Simulink research system, where you can create your own BCI, do your own research. You can use both boxes together, or could just use one of the boxes, only the auditory stimulation or the tactile stimulation, feedback, whatever you would like to do. Okay, so We go on with the headset. Usually we would measure the distance between nasion and inion to have the CZ electrode in the middle and also in the middle between the ears. But for this demonstration now I will save the time, spare the time to do this. And I have a lot of experience and I'm pretty confident that the position is pretty good. So we take our gel. Maybe you saw this also already in other demonstrations. We inject the gel via these holes into each electrode. If there's a bit of hair, try to move it slightly to the left and right. And fill all the 16 electrodes with electrode gel. It's pretty fast. And I do this just before I do the other setup of the mindBEAGLE, because then the gel has a bit of time to distribute on the skin, through the hair, create a better contact to the electrodes. And then when we have started the software, we can do a final check of the EEG. And never forget the reference electrode. This goes to the earlobe. You put a bit of gel on the electrode. Then fix it on the ear. Okay, you feeling okay, Sarah? All good? I just placed the headphones already. So we have an extension cable for the headphones. And for the demonstration, I just used audio splitter. It's not part of the mindBEAGLE system. I just use it so we can play the sounds via our loudspeakers. So you will be able to hear the same sounds that our subject is hearing now via Zoom, hopefully. So we have created extra long cables of everything because usually it could be that the patient is in a wheelchair or even in the bed, and you need long cables to be able to place the headphones and also the vibro-tactiles. You see, have extra long cables. So it's not a problem. So put it in your ears. All right. So I'm going to share my screen again. We'll just mute here the audio because otherwise we could have a feedback loop through the microphone playing sounds and so on. So Christoph, I won't be able to hear you for a while if you want to talk to me.
Okay.
Start with mindBEAGLE now. First, let's see, is everything switched on? Yes, so you need to switch on the Nautilus headset, of course, and connect all the boxes before you start mindBEAGLE. So this is the user interface of a sorry, mindBEAGLE. So we tested yesterday the system, or the whole session, of course. So I added already Sarah yesterday to the system, but I want to show you also how this would look like. So in general, you have one of these boxes for each patient that you have created. If you want to create a new one, you click here on the plus symbol, and then this window pops up. There's an ID. You can use your own IDs or have an auto-generated ID. Then you would enter name, birth date. You can enter anything if you feel you're too old to write your real age, like me. Then it's important to select the correct language because you get audio commands in some of the paradigms. So as you see, we have a big number of languages, some also in the local variant like Portuguese and Brazilian Portuguese, and also the European Portuguese. Same for the German, by the way, because yeah, for us it's sometimes, for the Germans it's sometimes hard to understand Austrian German. So I would choose this one, and then you could add some additional information like disease, but that's not necessary. And if all is fine here, you would just confirm and have a new patient. So you see here that the box is now empty because I didn't do any assessments with that patient, and the boxes here are already filled. So you see of which paradigm, how many sessions you already did, AEP 2 times, multi-imagery 1 time, vibro-tactile, and so on. And this plot here is one of the results. So it shows you like the best result, the best accuracy that was achieved with that patient, and it helps you a little bit if you have a big number of patients to recognize the one you're looking for. So we didn't want to add photos or pictures here, of course, so, but have something that is recognizable. Okay, I'm gonna continue now with Sarah that we have added yesterday. And if you select the patient, you see the screen is looking like this. You have the paradigms available that you can run, the auditory, the vibro-tactile 2 stimulators, 7 stimulators, motor imagery. Then we have a resting state data acquisition. This is for later offline analysis of EEG data that you could do with using GBS Analyze, for example. And then this button is if you did a mistake, you can edit the data of the patient, change anything here. And here on the right side, you could also transfer data. You could, if I would connect a USB stick, I can export data. I can also import data. So if I would have two mindBEAGLE systems. I could export it from one laptop and import it to the other. Delete raw data to save disk space, but that's usually not necessary because disk space is very big and it doesn't take so much. And move session to another patient. It could be, it happened in the past in our recovery system that when you have a lot of patients during the day, you forget maybe to switch patient after one session, the next patient would come in and you forgot to select another patient, then data is stored as the wrong patient. And with that button, you can move, if you did such a mistake, just move data result to another patient. And of course, you can delete patient files. I go quickly back to show another export. Okay, no, the USB stick is not connected, so I cannot show this now. There would be another global export import function, but it's only enabled if you connect a USB drive. Sorry for that. But yeah, not so important. Okay, let's start with our first paradigm, the auditory evoked potentials. You see here the result that we achieved yesterday. We had a successful test already. You see here two buttons, assessment and quick test. The quick test is only enabled if you did at least one assessment run, because the quick test uses a classifier that was created during the assessment. Since we did yesterday a session, this is also already enabled, but still on a new day, I would usually start doing an assessment because the signals could have changed of the patient, the positions of the EEG electrodes could have changed a little bit, temperature in the room and so on, everything could affect the signal, of course. So it's better to create a new classifier each day. And of course, we hope that the patients are recovering and then also the signals changed. It's the most important, of course. So I click here on the assessment. You see each time an overview. Okay, this is what you need for this paradigm. We just need the headphones in this case. You could adjust the sound volume here in the system, and you could, for explaining to the patient, play a target beep or a distractor beep. If everything is fine here, you continue. Now we have to check the EEG, but it looks at first glance already quite good. Maybe FC4 is a little bit noisy. If I click here on the channel, you see on the right side, this channel is marked, so it's easier to find the position if I don't know FC4, where is it? I click on it and see it marked here on the brain. And so I can try to improve the signal. You see now when I'm inserting the syringe, of course, while I'm doing that, the signal is fluctuating. Okay, let's see if it improved. Yeah, I would say so. Apart from that, signal looks very good. You could do still some basic checks if you have a subject that is responsive. That's not always the case for coma patients, so it's not really needed. But for the demonstration here, I could ask Sarah, for example, what would happen if she clenches her teeth. You would see probably a lot of noise. That's what you see here. And you see also in the signal quality brain here on the right side, channels are turning red if there's noise. Sorry, noise on the EEG signal. So that's a very nice and quick indication of the signal quality. You would also see if the patient is very relaxed. I don't know if Sarah can be now relaxed, but we can give it a try. If she closes her eyes, we may see some alpha waves. And yes, she's relaxed. It's good. You see here a bit of alpha also here. And here again, very nice. Thank you. So I think we're ready to start. I have to explain, of course, for a new patient, what is the paradigm. So she will hear beeps into different frequencies. a lower one and a higher one, and the low frequency beep will come more often, frequently, and just sometimes the high frequency beep by random will appear, and that's the target stimulus where the patient should focus on. So please count in your mind each time you hear the target stimulus. We will see the real-time EAP here on the bottom of the screen. I will just start the paradigm now and I can explain a little bit while it's running. So let's start. Maybe I increase the audio a little bit here so you can hear it. So you see here the green line is the EAP after the target stimuli, and the blue one is the EAP after the non-targets. We see a very big peak after 300 milliseconds already. It's always scaled to plus minus 10 microvolts, so EAP is just cut it here. We didn't want to have any scaling, any auto scaling, because this can be confusing, especially auto scaling if users are not aware of it, then the comparability of results would be negatively affected. If they get auto-scaled results, then yeah, they don't realize maybe what is a good or a bad result. So this is on purpose. And you still see that the peak goes way above the 10 microvolt, and that's enough. You also see here these green areas here, and there was shortly also one here that disappeared. These green areas show you the significant differences between target and non-target, between the green and the blue line. I can switch the view here to have all channels viewed at once. And it looks quite good on everyone, I would say. Here it's very nice. Although Sarah is maybe a bit distracted by my talking, she's performing really good. Can change back the view. And yeah, maybe I stop the run here because this takes a little bit too long. It's good to get boring, and we have assessment runs that are quicker. So I'm going to stop now. Thanks, Sarah. And we go back. And yeah, the result shows now, okay, we have aborted, of course. There's no result generated. I just click on continue. We can go back to see the results of yesterday. Selected like this. So this timeline shows you results. This was done yesterday. We had 2 results, one assessment run, one quick test run. If I have more than one result on one day, it is visualized like this. 2 results. I click on it and then I can select which one I want to see. So this was the assessment of yesterday. And you see here a nice P300 peak, and you see the accuracy plot goes up to 100%. We had 0 artifacts, and it was a very good and successful run. You can also switch here again to the view to view all channels at once. And yeah, again, you see the significant areas quite nicely. Let's continue to the vibro-tactile 2 stimulator paradigm. This is a bit quicker, so we can maybe finish one. So just go to the assessment. And here you see again showing you the setup. So by default, we put a green tactor on the left wrist and the blue tactor on the right wrist. But if you would like to change that because your patient has maybe no sensation on part of the body, you can click here on the edit button and move, let's say, the right wrist to the left ankle. And yeah, of course, you can move also the green one. Let's move it now back to the right wrist. Really, you fix the tactors with tape. I can show you also later on the VT7 how this looks like. For now, we just, because Sarah is helping me, I just ask her to hold the tactors in her hand, left and right hand, and for healthy users, that's fine. So let's continue. EEG is still fine. So now, similar approach like with the AEP, you have one tactor that stimulates frequently and one that stimulates rarely. That's the green one that stimulates rarely. And her task is to focus on the rare stimuli, count in her head each time she feels a stimulus on the green tactor. Let's just start. Green one, yes.
Left wrist.
Move the sound level a little bit. Okay, just looking at the watch, I think we also quit this so we can continue to the even more interesting parts, which is the communication. So we can go to a vibro-tactile 7 communication part. Before I quit, you already see here again the P300 is already developing nicely. And we would have a similar result as, now it's a bit of noise, maybe she's distracted, but we would have a similar result as with the AEP, of course. So let's stop this. So with AEP and vibro-tactile 2, you cannot do communication, you can just do a quick test. So these are the first steps to see if there's a response of the patient to our paradigms. And if this is successful, you would continue to the communication paradigms. Communication paradigms is the vibro-tactile 7 and the motor imagery. So let's go on with vibro-tactile 7. You still run this yesterday, as you see. I click here on the assessment, and here you see the more complex setup. So you have to place 7 tactors on the user's body, and we have a green and a blue one. These are the possible target tactors where you can focus on and use them for communication. The gray ones are just for distractors, so they're not used for communication, but just to provide the sequence of stimulation. Again, you could change the positions of any of them, so I could click here and move the right shoulder to anywhere else, but I don't do this now. And you could move all tactors to one side of the body, for example, if you know that your patient is not having sensation on the other part of the body. Let's continue here. And we have to quickly, I will stop sharing the screen and we finish the mounting of the tactors. So we have already placed tactors on the shoulders and on the belly, and in the hand she will hold it. So they're just missing the 2 last tactors, and these are placed usually on the legs. So they take a bit of tape. Okay. So I will share my screen again. And now we have these two target stimulators, the green and the blue one. And we need data of both so that we are able to communicate later. So this is why the system will tell the user now on which one to focus. So the first half of the assessment one will be to focus on the green one. And there will be the audio command via the headphones or the loudspeakers. And also it's good if you tell the patient during the assessment, please focus on this one, and then please focus on this one. So it's always good to engage more with the patient. And the second half of the run is then to focus on the blue ones. So I assume you're ready. I click on start.
Left wrist.
So now she focuses on the left wrist. You see it also here blinking. That's just to help the user, the medical staff to also know now the task is to focus on the green one. What you see here is a gray line and the green line. So the green line is the EAP after the stimuli on the left hand. And the gray line is the EAP after the distractor stimulator, so the shoulder, belly, and the legs. And as soon as we switch to the blue stimulation, where she's supposed to focus on the blue one, there will be also a blue line. So the blue is now also stimulating. Each one is stimulating with the same probability, the gray ones, the green one, and the blue one. But her task is to focus on the green one. This is why we don't plot the blue right now, and we'll plot it later when the task is to focus on the blue one. So now focus on the blue one.
Right wrist.
Now you see the blue line appearing. The 7-tactor paradigm, we achieved good results, better than the VT3. But it's also, I have to say, it needs maybe 2-3 sessions to get accustomed to the stimulation, because first time it's maybe a bit overwhelming if you feel stimulation all over your body in random order, and you need a bit of time maybe to get used to it. So yeah, let's see how it works. You see here these areas, so this is the difference of blue compared to the gray, and what we had before was the green compared to the gray. In this paradigm, in the communication, you can only focus on the green and the blue. I mean, you can also focus on the gray, but it makes no sense for communication. We only use the green and the blue to select binary answers. So now we are already almost done. Okay, thank you. So in the communication, first you would like to test the communication. So you would ask questions where you already know the answer, especially for patients, of course. So to see if the patient has a control over the system. So you would ask questions like, is your name Sarah or Chiara? If you know, of course, the name of the patient, and if she answers Sarah, then it was a correct answer, otherwise not. And you can ask, were you born in Austria or United States? Simple questions where you know the answer and that are easy for the patient to answer. And if this works out, if you get a good percentage of correct answers, you can go to the free questions. In the free questions, you don't know the answer, you can really use it for communication. You can ask, would you like me to turn on or off the television? Or you could ask for what you prefer for lunch, or everything else, of course. So processing should finish soon. We can go to the communication. Maybe Zoom is slowing down a bit the CPU. So processing takes longer than usual. No. All right. Result is not very good. It was in the test run yesterday. It was better, but it's explainable because the whole setup is stressy, and she's maybe listening to my stupid talk, and yeah, so that's excusable. So we have an accuracy of 54%. Yesterday we had 66. Still, the data is significant, so we are able to significantly distinguish between green and blue. Let's just save data and continue. And now we can go to the communication. And I click here on communication. This shows me now how was the setup during the assessment. So if I would have changed positions, it would show me the different positions. I can not change it here now because I'm using the classifier that was just generated. And it's important to use the same positions as was used while creating the classifier. So confirm here. And now I can type a question. So this is stored for later. We have stored the result, the questions and the results. So I have an easy question. Or Chiara. And then I say, I explain to the patient, I will ask you a question. Is your name Sarah or Chiara? If your answer is Sarah, please focus only on the stimuli you feel on the left-hand side, on the green ones. If you want to say the answer is Chiara, please focus on the vibrations that you feel on the right-hand side. And I can click here these three buttons if I know the expected result, also for later storing the results. I click what I expect. If I don't know the answer, I would click on free question. But now I know she's expected to answer Sarah, so that's what I will click. You're ready? And yes. She seems a bit nervous. So let's just start. So you see here the expected answer is the green one. And we will see in real time the classification. Now the trend is towards blue. See here the progress bar. And we're almost done. You see now it switched to gray. So this is the third option of result. It could be green, or blue, or gray. Gray is if result is not significant, if we don't know, if we don't have a significant difference between green and blue, then result is indistinctive, gray. So she doesn't know her name. Okay, can happen. Let's give it another try. Are you born in Austria or the United States? Let's give target now blue. So we say green is US, blue is Austria. So if you're born in the United States, please focus on the green ones. If you're born in Austria, please focus on the blue ones. All right, let's start. Yeah, now the trend is blue. It doesn't surprise me that blue in this case is maybe a little bit easier. I'm talking and correcting her, sorry. But in the assessment, the difference between blue and gray was a little bit more significant. If you remember these areas indicating the difference, then it showed a nicer result for blue. So in this case, it doesn't surprise me that she's a little bit better in focusing on the blue. I think in the beginning of the run, when she was focusing on the green one, she was maybe not yet perfectly into the task, and maybe she was more focused for the green one. We could ask a free question. Would you like to have schnitzel today for lunch, or would you rather like to starve, have nothing? Up to you now if you get lunch or not. So for schnitzel, focus on the green one. Oops, sorry. If you don't want lunch, just continue working. Up to you. Then focus on the blue one, and we ask a free question. You see here, this stays white, indicates that we asking a free question. And you saw this was green, we were expecting green one, and this is blue, we were expecting a blue one. And it seems Sarah doesn't like lunch. Okay. Yes, you will have lunch. Very good. I think this is what you wanted. Yes. Okay, so it's almost, yeah, some minutes before 10, so we can stop here. And I'm open for questions if there are any. If not, please visit our webpage.
Thank you very much, Robert. Can you hear me again?
Yes, I can hear you.
Thank you very much, Sarah and Chiara. Nicely done. Hossam wants to know what is the reason for the specific points you chose for the tactile stimulation, so hands, foot, leg, whatever.
They should be as far as away from each other as possible, because otherwise you could maybe not distinguish between them. So that's why we chose shoulders and legs and something in between. But that's just the default. As I said, you could also switch the positions. The auditory commands, by the way, are adapted. So if you move to the elbow, it will say elbow or left elbow. So each position has the audio command in the patient language, so you'll have it correctly played.
So could you maybe also put it on every single finger, or what would you get then?
We tried it with fingers some years ago, and it's sometimes hard to distinguish between single fingers, but in theory you can do it. Maybe also the vibration with those vibrators could be a little bit strong, but it could be an idea for a research project, so one could try.
Rastava wants to know, when you work with locked-in patients or DOC patients, does the time of the day or the season play a role?
Yeah, time of the day is a good point. So definitely, and it's a good idea to you anyway should try it many times, maybe 5 to 7 times at least, and then also try it at different times of day because patients are different, and it can be that they're more awake in the morning or more awake in the afternoon. So it's good to play around a little bit with the timing to see what works best.
Lisa wants to know if you can also use it for other patient groups, for example, ADHD, schizophrenia.
ADHD, yes, to train your ability to focus on a task. Schizophrenia, I'm not sure to be honest, but I'm not an expert in this. Maybe it's also feasible to use it.
You can, of course, use parts of mindBEAGLE as biomarkers just to see if you get normal auditory responses, normal vibro-tactile responses, normal motor imagery, just as an assessment tool, communication tool for schizophrenia. Don't know how much sense this make because most of the time they will be able to answer. Rastafa also wants to know, do you have any plans to go beyond the binary yes and no response?
Not at the moment, because for the group of patients we are usually using it, this is already a big step if you can communicate binary again if you were not able to communicate before. So making it more complex would be maybe overwhelming for the patient. So we want to keep it simple and have the binary communication. And for more complex ones, maybe you could use just a visual speller if you have better patients who can also view a screen. Of course, you can use visual piece-rounded spellers, for example.
So mindBEAGLE is more for professional users in a clinic, in a nursing home, where you have plenty of these patients to figure out fluctuations and what they can do. And of course, to have a rehabilitation protocol. Unicorn Hybrid Black with the speller is for people at home who can already communicate, who have vision, which are good enough. Locked-in patients, for example, are good enough to use it. They don't, you can use the mindBEAGLE first for locked-in patients to figure out if they have command following and everything before you're going to an eye tracker or P300 speller. Christopher is also, thank you very much for the nice walkthrough of the software. And Anikite wants to know, what's your opinion about neurocinematic research upcoming with EEG? This is, of course, a very nice area. And you can work it, for example, attention and engagement while people are watching a film. You can do hyperscanning experiment like McMaster University is doing it to see group factors, group biomarkers while a film is done. You can study memory formation. So there are many options for this research. And the main interesting thing is, of course, that many people are in the same room getting the same information, the same stimuli. Then you can also stream all the information from the EEG and BCI system to a master computer. You can even influence the film depending on the responses you get. So this would be a more interactive experience. McMaster University is doing this for concerts, music concerts, which is very nice. But of course, you can also do it with computer graphics. So Rupert, this was very nice. Thank you very much.